Hi everyone, it's Mr. Slavka. Today I wanted to talk to you about section 10.2, which is about finding arc measures. Emphasis on the word measure. So what I have right up here for you is a little warm-up about pizza. That's a nice circly shape that everybody is very familiar with. It says right here, a pizza is cut into 6 slices, 8 slices, or 10 equal slices. How would you find the measure of the angle at the point of each slice? So we're talking about cutting our pizza and forming some slices, and we want to know about the angle that's going to be occurring here at the center of the pie. Well, if the pizza is being cut into 6 slices, that would be 360 divided by 6, which would make that angle a 60-degree angle. That's very few slices, so the angle is rather large. If the pizza is being cut into 8 slices, it would be 360 divided by 8, which would give you a central angle of 45. That is more slices, so the central angle is smaller. And if the pizza is being cut into 10 slices, that's 360 divided by 10, which means that we are going to only have 36 degrees for our central angle right there. All of these are called central angles. This is very similar to what we had done in the last section of 11.3 that we had talked about. Let's talk about our other part right here. It says, you and your 5 best friends, there's 6 people in total. You and your 5 best friends want to order a pizza. Sir Pizza, the very best pizza shop in all of Rochester, Michigan, sells a 10-inch pizza with 6 slices or a 14-inch pizza with 6 slices. How does the diameter affect the slice? Well, if you have a larger diameter, then that means that you're going to have a larger slice, aka there will be more surface area. If you have a larger diameter, though, it will not affect the central angle. Regardless of whether it be a 14-inch pizza or only a 10-inch pizza, the central angle will still just be 60 degrees, the same 60 that we had calculated in the last warm-up problem. So this is an interesting thing right here. When the pizza grows, you will get a larger slice, but you won't get a larger angle. So that's an important fact that I want to make sure that we're clear on, because this guy right here, this no change angle, is going to be something that we're going to come back to in these notes today. All right, let's talk about our vocab. So our vocab right here is a mix of old and new, starting with the old one, central angle. Once again, a central angle is going to be an angle whose vertex is the center of the circle. This is exactly what we had seen in section 11.3. You can see this angle right here, ACB. Its angle measure of 50 degrees right here is formed by the center of the circle, which is point C. Now, there is another portion of this picture that I want to talk about. When you create this angle, you're also going to create this small portion of the circle right here, which you might call the crust of the pizza. That's called an arc. And that arc right there can be a couple of different shapes. It can be called a minor arc, a major arc, or a semicircle. Now, these names are very clear, and they do exactly what you think that they're going to do, which is great. Minor arcs are small. Specifically, they're going to be smaller than 180 degrees, and so they are going to be measured in degrees, just like our angle measure is, and it needs to be a small one. Major arcs are big. They are going to be large arcs that are going to be bigger than 180 degrees. A major arc that we have on this drawing right here is if we started here at A and we rotated counterclockwise to get to B. That right there, that angle measure, and this arc right here would match. That is a major arc. Semicircle. Semicircle is something you're probably familiar with. A semicircle is half of a circle, and it's going to have 2 segments like these guys right here, but they are going to be formed by the endpoints of a diameter. So your semicircle is going to be, once again, half. Measures. Measures of a minor arc are going to be the same as the measure of the central angle. Measures of the major arc are going to be the difference of that 360, which is 1 full revolution, and that minor arc that we talked about. I'll show you some examples of this, and I think that you'll understand it very quickly. Let's take a look at our first example right here, example number 1. In this example, it says, find the measure of each arc. So now some of these arcs I want you to notice are written with 2 letters. And when it is written as 2 letters, I want you to know that that is a minor arc. When an arc is written with 3 letters, that means that it is a major arc. So when you see 2 letters, expect to write down a small number. When you see 3 letters, you need to write down a big number. Let's do the first one, DE. So now what we need to do is we need to travel from point D over here to point E. Now you could travel clockwise, but that would be very far, and that means we don't want it because we want a minor. So what we're going to do is we're going to travel counterclockwise from D over to E, and we're going to make sure we don't intersect any other points in between. That right there is going to be an arc that is going to have the same measure as this central angle. We don't need to do any work. It's just 117 degrees. Now let's take a look at the second one, DFE. So now because there is this letter F in the middle, that means as you're traveling from D to E, you need to make sure you pass by point F. So we can't go in the same direction we went last time. We need to go down through point F and then to point E. Now that isn't very clearly labeled on our picture right here, but we can get it easily. That guy right there is going to be 360, which would be an entire trip around the circle, minus the minor arc, which is 117 that we already saw. The answer for the measure of the arc DFE is going to be 243 degrees. I want you to notice that both of my answers have degree signs on them. They all need to have degree signs on them. Let's do this one, DEF. So now DEF is interesting. It is going to be another larger arc, and so we're going to start here at D. We're going to go through E, and then we're going to pass all the way to F. So we will be going counterclockwise again. We're going to go in this direction right here. Now this one's an interesting one because the starting point and the ending point exists on a particularly interesting line. That line right there is called a diameter. And because it's a diameter, that means that this guy right here is going to be 180 degrees. It also means that that arc that we're talking about is a semicircle. The arc DEF is a semicircle. Semicircles and diameters are very closely related. When you have one, you always have the other. Let's take that and bump it up a little bit more. If you take a look at this picture, you'll notice that there's lots of arcs that are kind of sitting on top of each other, and so that means that sometimes you might need to put a couple of those arcs together. Right here, what I have is the arc addition postulate, and it's not very thrilling, but it is very helpful. The arc addition postulate says that if you take two adjacent arcs, or two arcs that are next to each other, you can add them up to give you a bigger arc. If we take arc AB, which is a small minor arc, and we take arc BC, which is another minor arc, we can add those together to get arc ABC. So that is going to be a nice convenient way to get that major arc without having to do any subtraction. Let's try it right down here. It says you join a new bank and you divide your money several ways. You are diversifying your investments. As shown in the circle graph at the right, find the indicated arc measures, then decide if it is a major or a minor arc. So right here, BD, that's only two letters, so I can tell right away that this is going to be a minor arc. BD means we need to start here at B and we need to travel to D. And when we do it, we need to do it in the shortest way possible. So you could go clockwise or you could go counterclockwise, but you need to do it the shortest way because it needs to be minor. There's only two letters here. So your best bet is going to be to go counterclockwise. We're going to go this way. That's because these numbers that we see here are much smaller than these numbers that we see here. So let's add them up. If I start here at B and I go over here to A, that'll give me 55 degrees. And then if I continue from A down to D, that'll be another 105 degrees. If I add those two together, I will end up with 160 degrees. That's my minor arc measure. It is less than 180 degrees, which works great. BCD, I notice that there's three letters, so that means that this should be a major arc. Whoops. There we go, major arc. And when I'm traveling from B to D, again, I need to make sure I meet point C in the middle there. So this time we're going to go from B over to C and then down to D. Once again, we're going to do this by adding up a couple of degree values that are given to me. B to C is 140 degrees. And then C to D is an extra 60 degrees. This number needs to be larger than 180, and it needs to also be larger than 160. And it's both of those. It's 200 degrees. Next, let's talk about a big and tedious topic right here. I want to talk about congruent arcs. So now, congruent figures are something that we spend a lot of time with. We spend a lot of time talking about congruent triangles and similar triangles, and we're going to try to extend that idea of congruence to arcs. Now, just like with the proofs that we wrote for our triangles and things like that, you have to be extra careful and you need to make sure you're following all the rules. So let's talk about it. For congruent arcs, what you really need to have, first of all, is you need to have congruent circles. Congruent circles are going to be two circles that have the same radius. So that is the most important key. It is that the radius matches. Now, to have congruent arcs, once again, you need to have those congruent circles, which we can see right down here. But you also need to have another thing as well. You need to make sure that the arcs have the same measure. So we're going to be looking for those degree values to match up as well. Now there are two things listed here, and I always need you to be looking for both. So if you take a look at my third example, you'll notice that I have got 1, 2, 1, 2, 1, 2 steps laid out for each. I want you to make sure that you're always going through both steps. Never skip. If you start to skip, you're going to get burned, and I don't want you to get burned. So we're going to make sure that we go through both of our steps each time. So let's take a look. We have the arcs BC, which is over here on the left, and then we have the arc DE, which is over here on the right. And boy, they look about the same. As I trace my pencil down one and I trace my pen down the other, I notice that I'm traveling about the same distance, so I'm feeling confident that they're probably both the same. But before I can say that, I need to make sure that both of these things are happening. First of all, are the arc measures the same? And the arc measures are the same. That measure that is the same is 75 degrees. They're both very clearly labeled, so I don't have to spend too much time worrying about what they are, but I do use it. Next, you need to make sure that you have the same circle or congruent circles. Well, luckily, these two arcs both live on the same circle, and because they live on the same circle, that means that that is really good news. So, step number 1 is a check, and step number 2 is a check, which means I get to say that BC is, in fact, congruent to DE. Make sure you do both steps. Let's do another one. This time what we're going to do is we're going to be looking at arcs AB, which is going to be right here, and we're going to look at arc CD, which is right next to it. Once again, as I'm tracing along the curve with my pen, they feel about the same, and so that makes me think that they might be congruent. And to back that up, let's talk about step number 1. We need to make sure the measures are the same, and they are. Both of these arcs have the same measure, and that measure for both of these arcs is 80 degrees. It's written right there. It is arc measures are always the same as central angles, and that's our central angle, so that is our arc measure. Now here's where things start to go poorly. In step number 2, you need to make sure it's on the same circle or have the same radius, and that's not true. The arc that has AB on it is a smaller circle, and the arc that has CD on it is a bigger circle. So not the same circle, not same radius. And because of that, that means that the first step worked great, but the second step failed. And as long as one step fails, it could be the first one or it could be the second one, but as long as one of those fails, it means that they're not congruent. So I have to say that AB and CD are not congruent. So I'm going to put a big cross through my congruency sign right here to let them know that no, these are not congruent. Last one. FG and HG. I want you to try that one out on your own. See if you can determine if FG and HG are congruent. Pause the video right now and I'll post the answer in a couple of seconds. Here's the answer for FG and HG. FG and HG are in fact congruent. They have the same measure, which is 90 degrees. You can see it marked by those perpendicular angles. And they have the same radius. You can tell by the tick marks here by F and the other tick mark here by H. Next, we've been spending a lot of time talking about angle measures, and we've been talking about central angles, and we've been talking about arc measure. Another word that you're going to see pop up in the near future is the word length. And a lot of times what people are going to say is the word measure and the word length are the same. And unfortunately, in this chapter, the word measure and the word length are very different. And so I wanted to point that out to you to make sure that you're clear on that before we go any further. Measure, what we've been talking about today, is based on the central angle. And it is measured in degrees. That is very clear and very consistent. This is exactly what we've been doing. In the near future, you might start to talk more about length. And length sure sounds the same as measure, and in a lot of cases it is, but in this case when you're discussing arcs, length is based on the distance traveled, and it is measured in inches or feet or yards or meters or miles or light years or some other unit that is not degrees, and so that is going to be very, very different. This one is tougher to find. There are formulas for it. Arc measure, there are no formulas for it. It's very straightforward to find. It's very easy to find, so that works out really, really nicely. Okay, second you-try problem. Down there at the bottom of the page, there's a beautiful drawing. I'd like you to try out answering all the questions down there at the bottom. I will post the answers for that you-try it problem in a couple of seconds. Please pause the video now, and I'll post the answers. Here are the answers for your you-try problems. So right here, we're talking about BCA and ABC. Those are from the front side. You just need to do a little bit of adding or subtracting for the BCA. And for ABC, let's do that one. ABC is going to be a little bit more adding and subtracting. ABC is going to be 55 plus 140. 55 plus 140 is going to get you up to 195 degrees. Okay, so now down here, down below, what we have is we were given one piece of information, which is MHS, and you can see that marked very clearly. You're also given this little label right here on your drawing, and you're going to use that to answer a lot of questions. I want you to notice that some of the questions are about angle measures, and some of them are about arcs. And so I want you to also notice that a lot of the information is very, very consistent. It's almost the same. So this is a question about an angle measure, and it matches with that arc right there. So this angle, MAH, and that arc are going to be consistent. They're going to be the same. Next, SAH. SAH right here is going to be this very small angle. That angle is going to be formed by using the 90 degree that we just had originally given to us right here, and subtracting the 75 that we just found. We're basically removing this portion of the angle, or this portion of the arc. That's going to give you a very small angle of 15 degrees. Now let's transition to arcs, HMT. HMT is going to be the entire top portion right here. That's a semicircle. HT is a diameter. And so, because of that, it is going to be 180 degrees. Next, MT. MT is only 2 letters, so that means it needs to be less than 180 degrees. That's this guy right here. If you know you have a semicircle for the entire piece, you can subtract the 75 again, just like we did right up here with our 90, and that will give you your smaller minor arc, MT. Lastly, TAS. TAS is transitioning back to an angle measure. This angle measure right here should be relatively large, should be relatively close to 180. And that is because it is. The only thing you need to remove from the 180 is this small angle that we had found earlier, 15 degrees. When you do that, you get 165. Bouncing back and forth between arc measures and angle measures is going to be something that is very important to me. Okay, if you have any questions on this lesson, please send me an email or mention it in the Google Classroom. And now, please try out the worksheet. Thank you so much.